Alright, here we go. Let's go ahead and do part 2 of solving exponential functions. Quick review from the last video, and then we'll go on to ones that involve fractions, Okay, first thing we want to do is find a common base in this problema. Now the first thing we want to do is, well, let's write 6 and 36. Well, let's try to find a common base, right? Well, I can rewrite 36 as 6 squared, right? So I could change this problem as 3x plus 2 is equal to, I can write this as 6 squared. All right, now I can set these equal to each other, and I can solve for what number, if I plug back in for x, I should get 2, right? I'm trying to get these two sides to equal each other, so I set these equal to each other. 3x plus 2 is equal to 2. All right, here we go. And then now what we want to do is we want to subtract 2 to both sides, and we're going to get 3x is equal to 0. Right, this is a multiply, and we divide by 3, and we get x is equal to 0. All right, there we're done. If you plug this back into our equation, we'll see that we're going to get both sides to be the exact same thing. All right, we plug in 0 into here. All right, we plug in 0 into here for x, and we're going to get 6. This is just 0. 3 times 0 is 0. We get squared. It's equal to 6 squared. All right. Now, some of you might be confused and you're not maybe sure of how to determine whether something like this is one solution or two solutions or zero solutions for problems like this involving exponentials with power functions, right? Well, if we look at this right here, let's graph 3x plus 2. It went up by 2, and it's just kind of dilated. The slope is just changed, all right? So when it equals 2, right? Well, that's just right here at the y-intercept. So that occurs when x is equal to 0. So it's only one solution. All right, let's look at an example problem that might be a little bit more challenging for us to solve. Let's look at this right here. So we have 4 over 9 and 81 over 16. So I'm going to go ahead and write 4 over 9 over here and 81 over 16 right over here. And I'm trying to find a common base. All right, well, I can probably reduce 4 and 9 as 2 squared and 9 squared, but before I do that, I just want to see if I can reduce this so that this has a 4 and a 9 in it, right? So I look at 16. To me, I kind of notice 4 squared, all right? 4 squared is 16, which has a 4 in it. So I can rewrite this as 4 squared down below here, and I see that there's a 4 here and a 4 here. So I'm getting close to making both sides look identical to each other. Well, I'm just going to try, if 4 squared is 16, well, what is 9 squared? Well, that's 81. All right. So I'm just trying to, because I know there was a 2 here, so I'm going to do 9 squared. All right. Now all I need to do is, I know I have 4 over 9. I have 9 over 4. All right. And I need to flip them, right? So we're going to get 4 over 9 is equal to 4 raised to the negative 2 divided by negative 2. So you can see now I have pretty close to at least these numbers being a 4 on top, a 4 on top, a 9 on the bottom, a 9 on the bottom. But I still need to get a common base. So over here, I'm going to go ahead and get started writing this out. We have 4 over 9 to the x. We wrote this as 9 squared over 4 squared. All right. And then we're going to rewrite this as 4 over 9 to the x is equal to 4 to the negative 2 divided by 9 to the negative 2. All right. Now what I'm going to do is use the power over power property. So we're going to get 4 over 9 to the x is equal to 4 over 9 to the negative 2. Well, this may seem kind of confusing at first, but let's just look at this right here of why this is possible. What is the exponent on the 4 and the 9? Well, the exponent is just 1, right? Well, negative 2 times 1 is 4 to the negative 2. And negative 2 times 1 is 9 to the negative 2. So we get exactly where we were right here. All right? So, but all I'm doing is just pulling that power out. So I'm pulling the power out. And if you look now, if we look now, we have 4 over 9 in the parentheses, and we have 4 over 9. So we have an identical common base. Therefore, x has to equal, well, we set them equal to each other. X equals negative 2. All right? Let's go ahead and do one more example problem. All right, let's look at this here. I'm going to write 2 over 3 over here and 27 over 8 here. All right. Well, I know that there's going to be a 2 and a 3 somewhere here. I know this has to be the common base. So I'm looking at 8. How can I rewrite 8 so that it's either a 3 or a 2, right? Well, you could try 3 squared, but that's 9. So you know 3 doesn't work, so let's try 2. All right, what's 2 times 2? Well, that's 4. That's not going to work, right? This is 2 squared. All right, well, let's try 2 to the third. This is 2 times 2 times 2, which is 8. All right, so we can rewrite this as 2 to the third. 2 to the third equals 8. So I can rewrite this as 2 over 3, and over here I could write this as 2 to the third. And up here I can write this as, well, I'm just going to check. I bet you 3 squared is 27, right? 3 times 3 is 9. 9 times 3 is 27. So that definitely works. So 3 squared equals 27. Okay. Well, just like before, the 2 is on the top, the 3 is on the bottom, the 3 is on the top, the 2 is on the bottom. I want them to be identical to each other. So what I'm going to do is I'm going to flip them. So 2 is going to be negative 3, and then 3 to the negative 3. Remember when I flip them, when we take the reciprocal and flip them, right? 2, put them on top, and 1 and the 3 on the bottom, the exponents become negative. So I'm going to go ahead and get started right here. We rewrote this as 3 to the third power over 2 to the third power. And then what we did is we had 2 over 3 to the x is equal to, we had 2 to the negative 3 over 3 to the negative 3, right? We just flip them, which changes the exponent. So now we have 2 to the 3 raised to the x is equal to, I'm going to pull out, just like before, the negative 3 and put it on the power, right? I'm pulling out this negative 3 and I'm pulling it out here. I'm kind of going backwards. All right, now I set the exponents equal to each other, and we get x is equal to negative 3. And we're done. The problem is solved, and we have officially finished the problem like this.